Hi everyone. I'd like to talk about abbreviated truth tables. This is problem 7.4a, number 5 from your homework from Logic Tutor. Now, when you're doing an abbreviated truth table, the key idea is that you are assuming that the argument is invalid. When an argument is invalid, it's always possible for all the premises to be true while the conclusion is still false. So when you assume that it's invalid, you're assuming that we can assign a set of truth values where the conclusion is false and all the premises are true. The easiest way to approach this is to start with the conclusion. We're going to start by assuming that the conclusion, not P, is false, and that means, of course, that P is true. Then we're going to mark all the premises as true. There's only two premises. The whole argument is if P and Q, then R. And then the second premise is not R. Then the conclusion is not P. So we're going to mark this one true. We're going to mark under the arrow there, the main operator, true for the first premise. Since we know that P is true, we can fill that in over here inside the parentheses. We also know if not R is true, then R must be false. So we can go ahead and mark that. And if we know that R is false, then we know that it has to be false over here as well. Now, how do we make progress? We've gone a good ways. We've got a value for not R. Now, in the first premise, what we've got is a conditional. We've got the consequent R is false, and we have a conditional right there. Conditional, we are assuming is true. How is it possible to have a conditional that is true while the consequent is false? Well, there's only one way. The only way to have a true conditional with a false consequent is to have a false antecedent. And what that tells us is that this conjunction here, this P and Q, has to be false. And so let's go ahead and mark it as false. But if it's going to be false, we already have determined that P is true. So that must mean that Q is false. That's the only way a conjunction can be false. Oops, not a Q, false. Q has to be false in order for the conjunction P and Q to be false. The only way a conjunction can be false is if at least one of the conjuncts is false. And notice we have filled in truth values over on the right hand side here for everything. And that means that we're ready to plug the truth values over here on the left hand side. This is the last step. This is not the first step. You don't try to do this first, and you don't try to do it along the way. You wait until you've figured out a set of truth values for everything, and then you plug truth values in over here to the left. And so we put in T for P, we put in an F for Q, and we put in an F for R. And if we're correct about this, if everything here makes sense, this should be invalid. It looks like we have a false conclusion with a true first premise and a true second premise with these truth values that we're assigning right here. And having a possible arrangement of truth values that allows for the premises to be true while the conclusion is false is a definition of an invalid argument. So let's click the button and see what we've got. We did it. The argument is invalid. If we assign these truth values, we've achieved a proof that the argument is invalid. Thank you.